So what we're going to do today is we're going to do Trigonometry 2. Trigonometry 2 has to do with the sine and cosine rules. Now, Scotia and Shazay, have you all ever heard or saw anything about the sine and cosine rules? Now, this is very much Form 5 stuff, right? Now, we just did Trigonometry 1, and we saw that we were dealing with right-angled triangles. And with right-angled triangles, we had these special ratios. And we learned these ratios like a formula, SOHCAHTOA, sine, cos, and tan. And we saw that the hardest thing, so we have these formulas, sine, cos, and tan, SOHCAHTOA. And really the hardest thing about Trigonometry 1 is making sure that you're dealing with the correct sides and the correct angles. Making sure that you know who is adjacent and who is opposite when you're doing the formulas. And I think that that is the hardest thing and the part that gives students the most problems with Trig 1. Trig 2 is very much the same thing. At the end of the day, you're going to learn a couple of formulas, right? And it's just a matter of you knowing the formulas. But again, the hardest thing about the formulas are going to be deciding which sides to use. Yeah? Now, the coolest thing about Trig 2, the sine and cosine rule, is that these two formulas can be used for any triangle, right? So we saw that in Trig 1 we had sine, cosine, and tan. And those formulas could have only been used for right-angled triangles only. But what if we don't have a right-angled triangle? Once you have a right-angled triangle, you're easy. You could use trigonometry, sine, cos, tan. You could use Pythagoras. Once you have a right-angled triangle, you have plenty of options. But what if you don't have a right-angled triangle? Yeah. So if you don't have a right-angled triangle, thankfully we have the sine and cosine rules. So this is what we're going to look at today. Remember, with Trigonometry 1, we could have only dealt with right-angled triangles. But with Trigonometry 2, we could deal with any triangles using these formulas. So let's just remember the elements of a triangle. Remember that the corners or the angles are named by the vertices in capital letters A. Yeah? So if you see a capital letter B, they're talking about that corner B with the angle B. Yeah? And remember that opposite the angle B, I will have the side B. Opposite the angle A, I will have the side common A. Opposite the angle C, I will have the side common C. So the angles are in capital letters and the sides opposite the angle will be in common letters. Everybody okay with this, right? We saw this when we did the elements of a triangle back in geometry. So when we're dealing with a triangle now, the first rule that we're going to deal with is the sine rule. And take a look at the sine rule. This is the sine rule. They say that the side A over the sine of the angle A is going to be equal to the side B over the sine of the angle B, which is equal to the side C over the sine of the angle C. Right? So give this a write down real quick. Draw this triangle next to it. This is the sine rule here, and we are going to see how to use the rules. So write this down, draw this, and let me hear done it when you finish. So let's see how to actually use this formula. And I want you to make a note of something, right? Note that these A's are together. The side A and the angle A are together. The side B is together with the angle B. The side C is together with the angle C. So make a note of that. And let's see how to use the sine rule, right? So we can see here that we have a triangle, right? And we have to find x. So x is the length of this side over here, right? Given your answers to 3 significant figures. Well, okay. Now, how do you decide to use the sine rule for this? Right. Well, first of all, we're looking at it and we're seeing, well, it's not a right angle triangle. You know, if you wanted to, you could calculate this angle here. But it certainly is not a right angle triangle. So how do I decide which rule to use? Well, you'll notice something, right? That I have to have, if you want to use the sine rule, I have to have 2 sides and the 2 corresponding angles. So once you are dealing with 2 sides and their corresponding angles, right, then you could use the sine rule. Now in this case, what do we have here? We have the angle B, and you know that this is going to be the side B. Yeah, so we have the angle B and we have the side B. And we have the angle C and we have the side C. So we could see here that we could use this part of the sine rule, right? Where we have the side B and the angle B, the side C and the angle C. So once you have 2 sides and their corresponding angles, you should start to think about the sine rule. That is 2 sides and 2 angles. So we could see here that we could use B sine B is equal to C sine C. And what do we want to find? Well, we want to find B. B is the side. So we call in B X centimeters. So B is what we want to find. So you know, it's just a matter of taking the sine C and flinging it across. And boom, you're done. Yeah? So at the end of the day, remember, we'll just substitute B is really X. The angle B is 51 degrees, so it's X over sine 51 is equal to 18 over sine 75. Right? 18 is the side C, and the corresponding angle is the sine of 75. And that is all that there is to it, right? Now we could cross multiply. You don't really have to cross multiply though. You can literally just fling the sine of 51 across there, and boom, you'll find for X, right? But I cross multiplied. I took the sine of 51 and put it over here, so it'll become multiplied by the sine of 51. And then I took the sine of 75 and I threw it over here, so it becomes multiplied by the sine of 75. And then, well, look, I just throw back the sine of 75. So really and truly, you could have gone from here straight to here by just flinging across the sine of 51, and you would have reached here. You didn't have to cross multiply. Yeah. So it's just a matter of punching it in your calculator to get X is 14.5. Now this is pretty much the sine rule. The sine rule is super easy to use. The hardest part part about it is deciding when do you need to use the sine rule. And if it is that you don't have, once you have a right angle triangle, you shouldn't even be thinking about this. Once you have a right angle triangle, you're supposed to be thinking normal, sine, cos, tan. You're supposed to be thinking Pythagoras theorem, right? That is a normal right angle triangle. But once you're not dealing with a right angle triangle, well then guess what? Sine, cos, tan not going to work. Pythagoras not going to work. So once you are not dealing with a right angle triangle, the sine and cosine rule will work for all other triangles, right? So does everybody understand how to use the sine and cosine rule? So in terms of when should I use the sine rule, you want to check two things. When should I use the sine rule, right? The first thing you want to check is if it's a right angle triangle. So it's not a right angle triangle, okay, good, right? Next thing is there two sides and two angles involved? Once it has two sides and the corresponding angles for those sides, well then the sine rule should be obvious, right? So everybody write this down, everybody finish write this down. For the sine rule, you could see that we use two sides and the two angles that correspond with those sides. So once you have that, then you could use your sine rule. Do this question. What do I do? Well, the first thing I'll ask myself is this a right angle triangle? Because then I could use sine, cos, tan, or Pythagoras. Well, I can't use Pythagoras. That have nothing to do with angles. But it's not a right angle triangle. I have nothing here to tell me that it is. So, okay, since it's not a right angle triangle, the first thing I'll think about is sine and cosine rule. What do I have? I want to find this angle. Do I have the corresponding side? Yes. So I have the angle B and I have the side B. Well, I want to find the angle B. I have the angle C and I have the corresponding side C. So good. So now I'll quote my sine rule. The sine rule is B over sine B is equal to C over sine C. So Soraya, you okay with this so far?
Yeah.
Alright. Now let me plug in the values. The side B is actually 20. Right? That is small b, so that is 20. Right? 20 all over. So we see that the side B is 20 all over the sine of the angle B, which is what we want to find, which is x. And that is equal to the side C, which is 22, all over the sine of the angle C, which is 48. And now it's just about making x the subject of the formula. Right? So with this one, I should probably cross multiply. So I'll cross multiply, I'll fling the sine x over here, so it'll become multiply by sine x. And then I'll fling the sine 48 on this side, so it'll become 20 multiplied by sine 48. So 20 multiplied by sine 48 is equal to 22 multiplied by sine x. Soraya, you okay so far? Alright, nice. Well, let me just do it over one more time from a Form 4 student so she could feel included, right? So we see here that the side B is 20, right? All over the sine of the angle B, which is x, which is what we want to find. And that is equal to the side C, which is 22, all over the sine of the angle C, which is sine of 48. So Soraya, this is divided by the sine of x. So if I fling that across, I'll just have 20 alone on this side. I'll have 22 all over the sine of 48 on this side, and that will be multiplied by the sine of x here. So you understand that? Because remember, when in algebra, if you divide it and you fling it across, it becomes a multiply, right? You get what I'm saying? So in this case, I'll take this one now and I'll fling it across, right? Because I have a divide here, so I'll fling it across. So when I fling it across, it'll become 20 multiplied by the sine of 48. And that is equal to this 22 multiplied by the sine of x. You understand that now?
Yeah.
Right. So now, let me just flip it. 22 multiplied by the sine of x is equal to 20 sine 48. So now I could take this 22 and fling it across. The sine of x is equal to 20 sine 48. And that 22 is a multiply on this side. So when I fling it across, it'll become a divide. Right? So now we can actually work out the sine of x to be, on the calculator, 20 multiplied by the sine of 48 is equal to that divided by 22 is equal to 0.67558. The more decimal places you have, the more likely, the more accurate you'll be. So therefore, x, which is the angle we want to find, is the sine inverse of 0.67558. X will be, so the sine inverse of the answer is 42, around 42.5 degrees. We're dealing with the sine rule here, and we can see that we want to find the angle B, and we have the side B. We have the angle C and we have the side C. So okay, you're dealing with two sides and their corresponding angles. So I will start to quote my sine rule. Sine B. Sorry, that is not the sine rule. Grr. The side B over the sine B is equal to C over sine C. That is the sine rule. So now it's just a matter of plugging in the values. So the side B is 20 all over the sine of B, which is x. That is what we want to find. We want to find x here. We don't want to find sine x. We want to find x, right? That is equal to C, which is 22 all over the sine of C, which is sine 48 degrees. Right? And now we just cross multiply. Right, so the denominator of one side is multiplying the numerator of the other side. So now we'll have the sine 48 being multiplied by 22 on this side. No, sorry, by 20. Right, the sine 48 is coming across to multiply by the 20. And then the sine x is going to come across to multiply by the 22. Right? And we did many of these cross multiplications when we did algebra. Yeah, just flinging things across, transposition. I could actually take this 22 and fling it back across. So I'll get sine x alone on this side is equal to this 22 is multiplied, it'll become divide. So sine 48 times 20 divided by 22. Now it's just a matter of working it out. Sine x is equal to, punch that in a calculator, sine 48 times 20 divided by 22 is 0.67558. Therefore, x now is the sine inverse 0.67558, which is sine inverse of the answer is 42.1. Oh no, 0.5. Sorry, 42.5 degrees. So Shizzy, how is it now? Is it okay now? Better? Okay. Just draw this and write this down here. You'll notice something. We have the two sides and we have the included angle. So when we have two sides and the included angle, we use the cosine rule. Right? So write that down and let me hear 3 donuts for the cosine rule. With the sine rule, we needed two angles and their corresponding sides. But with the cosine rule, what do we need? Is we need two the angle and the two sides and the included angle. Now I'm going to show you the cosine rule and how it does look. And you're going to get a minor heart attack. And I'd like you to just kind of hold your breath so that you don't have a pulmonary aneurysm, right? So this is what the cosine rule does look like. Right? Now the cosine rule, it looks like 3 different formulas, but it's actually just one formula. It's actually just one formula, right? And the formula actually comes out of Pythagoras' theorem. You can kind of see the Pythagoras theorem in it. Yeah? And how the formula does go is like this. If you want to find one side, right? Like let me just say you want to find the side A. Right? Then you'll add the other two sides minus 2 multiplied by the other two sides, but then multiply by the cos of the angle of the side you want to find. So if you look at it here, right? This is A is equal to, in the formula, the only other A is the angle itself. Yeah? And everything else is the other two sides, B and C. Yeah? So, the cosine rule, oh, and by the way, and you all will smile for this one, but the sine and cosine rules are usually included in your formula sheet. So if it is that you're having problems remembering them, I really do think you should learn them. But if you're having problems remembering them, they are in your formula sheet, right? However, things like Pythagoras' theorem, sine, cos, and tan are not in your formula sheet. Yeah, so you don't have everything in the formula sheet, but sine and cosine rule is in there. So read this off. If you look at it, if B is the side that I want to find, then I will use the other two sides, add them, add the squares, right? Then I will minus 2 multiplied by the other two sides, cos of whatever it is I want to find. So this is the cosine rule. A squared is equal to B squared plus C squared minus 2BC cos A. You don't really have to write down these two. It's all the same. Alright, this here is basically it. The side that you want to find, well, that is the angle that you're going to be using. And then you just use the other two sides over here. So everybody understand how the cosine rule does look? Right? Give it a write down and let me know when you're done it. Draw this diagram and write down these 3, but remember it's just one rule. It's just really one formula. Now let's take a look at this question that we had before. Find the triangle below, find x, and we see here that x is the side that is opposite to the 60, right? So what do we want to find? We want to find b, right? And we have the angle b, right? So you can see here that we want to find b, so b will be at the beginning of the formula. And then it'll be the cos of the angle b at the end of the formula. And then the other two sides will be all in the middle of the formula. So can somebody quote what this formula is going to be? That is the one that I'm going to use. Alright, remember, it's all three of them is the same formula, yeah? Alright, b squared is equal to the other two sides. So you can see why. When you see a triangle and you have two sides and the included angle, you should be thinking about your cosine rule, right? Now, all you have to do is plug in your values here. So I have the 28, I have the 29, right? Minus 2 times 28 times 29 times the cos of 60, and that will give me the answer b, which is x, which is 28.5. So it's actually, so you can see here, the formula might look intimidating, but it actually is not really that tough. Just like trigonometry 1, the hardest thing is deciding which formula to use based on what sides and angles you have. And again, if you have two sides and the included angle, you want to use the cosine rule. Right? So write this down, let me know when you're done it. What do you have? What do you want to find? And of course, you can see here that you want to find the angle, right? So you want to find the angle A. So at the end of the formula, you should have the cos of A, yeah, and of course you want to make the cos of A the subject to the formula, and then find the cos inverse in order to find A. So 5 minutes.
Yes.
So at the end of the day, we could see that I want to find the angle A. So that means that in the formula I'll need the cos of A. So that means that I'll be using this formula. A squared is equal to b squared plus c squared minus 2bc cos A. Right? And it's just a matter of making the cos of A the subject of the formula. So let's plug in the numbers and see. So a squared, well, this is A, right? This is b from the angle B, and then this over here is C. So a squared, which is 14 squared, is equal to b squared, which is 13 squared, plus c squared, which is also 14 squared, minus 2b, which is 13, c, which is 14, multiplied by the cos of A. Nice. Okay. Well, all of this multiplied, so I'm treating all of this like one unit, right? So I ain't gonna touch that yet. Let me work out these guys here first, right? So 14 squared is what? 14 squared is 196. And that is equal to 13 squared is 169. That's interesting. Plus 196 minus, and let's make this multiplication here, right? 2 times 13 times 14 gives us 364. So 364 multiplied by the cos of A. So all I did was plug in the numbers and expand on them, right? So 196 is equal to 169 plus 196 is 365. This is 365 minus 364 cos of A. Right? I can't minus these two because this 364 is being multiplied by the cos of A here. So what I will do is let me fling across this across here. Well, let me flip the whole thing first. So on this side I'll put the 365 minus the 364 cos A, and that is equal to 196. I'll fling this 365 across. So all I'll be left with here is minus 364 cos A is equal to the 196. And then on this side it was plus 365. So on this side it'll be minus 365. Right? So 196 minus 365 is equal to minus 169. So therefore, negative 364 cos A is equal to negative 169. Makes sense. Because at the end of the day, this was 196, this was 196. So the two of them would have cancelled off and you would have just ended up with 169. Now I could take this and fling it across. So I'll have cos of A is equal to negative 169 being divided by negative 364. The negatives will cancel here. So this will end up being 169 divided by 364 is equal to 0.464. So we try that. 4643. Right? So therefore, A is equal to the cos inverse of 0.4643. Right? A is equal to the cos inverse of that is around 62.3 degrees. How will you feel about it?
It's actually not hard, it's just long.
Yeah, it's long and not hard. It does look hard though, but it's not. It's just once you know your formula, just plug in the values. But the most important thing is make sure you have your sides correct. So you can see I went and I label all of my sides here. If this is the angle A, that means that this will have to be the side A. You can't use anything as the side A, right? It has to be the opposite angle. Scotia, how you feel about it? Alright, nice. So, sine and cosine rules. I'll give you guys, just now, let me see what we have again to do. Sine and cosine rules. We have a few questions here. We have a worksheet here. And then we have to do this. Now this here I will do next week, next class. So we don't have to worry about this class, right? So let's just do some of these questions. You have, huh? No, it don't have a tan rule. It's just the sine rule and the cosine rule, right? The sine rule and the cosine rule just generally handle everything. So let's do two of these, right? Actually, let's just do one. Let's try number 3. So try number 3 here for me. And even if you err done it, if you just give up, just say done it. Even if you err done it, right? In fact, you all should do this. I'll give you all a hint. You might not even have to use sine and cosine rule for this one. All right. So at the end of the day, let me look at what we have. Remember with the sine rule, right? With the sine rule, I wanted to have an angle and the corresponding side, and then this angle and the corresponding side, right? So that is what I'm looking for the sine rule. So let's see if I have that. I have this angle, but I have no corresponding side. I don't have that side, all right? Where's the side they want me to find? They want me to find BC. So they want me to find this side here. This is BC, this is the side A, because it's opposite the angle A. Yeah? So what do I have? I have two sides and the included angle. So, but I don't have this side. So, you know, maybe I can't use sine rule. Maybe I can't use cosine rule. I don't know. What do you think is the first thing I should do here? What do you think? Right. Well, what I noticed here is I have two angles. And well, we know that we could find the third angle, right? So 180 degrees in a triangle minus the 39 plus 51. And what does that give me, Scotia?
I see.
90 degrees. So that means that this is 90 degrees. And if this is 90 degrees, then this is a right angle triangle. So I don't have to use sine and cosine rule at all, right? I could use some other trigonometric function to find A. Anybody wanna tell me? And Soraya, you should be able to know this. What can I use to find this side here? Right, and I'll just write on the side here, so So what do I have? I have the hypotenuse, which is this, right? So that means that I could use sine or cosine, right? And this, which is what I want to find, is the adjacent to this angle. So the adjacent and hypotenuse means that I'll use cosine. Yeah? So the cosine of 51 degrees is equal to the adjacent, which is A, over the hypotenuse, which is 27. So I'll fling the 27 across. So therefore A is equal to 27 multiplied by the cos of 51 degrees. A is equal to 17, around 17, or 16.99. Did you get that, Scotia?
Yeah, I put 7.
Alright, you put 17. Did you use this or did you use sine and cosine rule?
I use sine.
You use the sine rule? Or you use sine over here?
Yeah, I use the 39.
Oh, you used the 39 degrees, but then you had this, so that means that you found this? Oh, no, that is the opposite. Okay, alright, sure, yes. Okay, nice. Okay, good. Right. Shazay, how you felt about this one? This one didn't end up being a sine cos thing. So were you flabbergasted by it?
Yeah, I didn't get it out.
You didn't get it out?
I was trying to use sine rule, and then you see how we might not need to be sine rule. I just started confused as to what it is.
Right, I see. But you didn't think about the fact that you had 3 triangles in here, right?
No.
Alright. Now let's see if we could have used the sine rule here. I wonder if we could have, right? Or the cosine rule. If this is the side A that we want to find. Alright. Let's see if we could really use one of those rules, right? So we know we want to find the side A. So A squared is equal to B squared plus C squared minus 2BC cos of A. Do we have the angle A? Yes, we do. Right? Do we have the other 2 sides? No, we don't. Remember, in order to use the cosine rule, you have to have 2 sides and the included angle. So we do not have 2 sides and the included angle. So we can't use the cosine rule here. Right? So we rule that out. Let's try the sine rule. Sorry, that's not the sine rule. A over sine A is equal to B over sine B is equal to C over sine C. Right? We already worked out that this was 90 degrees here. We see that we have A and we have the angle A, and we have B, which is 90, and we have the side B. So yes, we could use the sine rule here. Yeah, so we could say that A over the sine of A, which is 39, the sine of 39 is equal to B, the side B, which is 27, which is the hypotenuse, over the sine of the angle B, which is 90. Right? And now we could just say that A is equal to 37 over the sine of 90, all being multiplied by the sine of 39. And A is equal to 37 divided by the sine of 90 is 37, because the sine of 90 is 1. Right? 37 multiplied by the sine of 39. Ooh. 50. What did we get last time? What was the last answer we got?
Something.
Alright, just now. Something went off there just now. This is B. So this is the side B. Right? This is A, and this is the side A. So A, or maybe it is that you can't use the sine rule because it's a 90 degree angle. The sine of this is 1. Oh, I know what I do wrong. Oh gosh, look, I have 37 here instead of 27. That is what I do wrong. Sorry. Alright, so everything correct. Yes. Instead of putting 27, I'll put 37. So it's 27 multiplied by the sine of 39. And we got our answer 17. Alright? So you see how I actually used the sine rule here. But you see, Shazzy, how I decided which one to use?
Yeah.
Alright, nice, right? So just look at what you have. Literally write down the two formulas and look at what you have and see which one to use. Let's just do one more, right? Let's do... Alright, let's just do this one. You gotta find BC. And we're sure that this is not 90 degrees, because look, these 93 degrees here. So we gotta find the side BC, 5 minutes. First, let me label everything properly. So this is the angle A, which means this is the side A. This is the angle C, which means this is the side C. This is the angle B, which means this is the side B. So I have the side B. What do I want to find? I want to find the side A. That is what they're asking me for. So let's just see if I could use the cosine rule. If I want to find the sine A squared is B squared plus C squared minus 2BC cos of A. Alright, what do I have? Do I have the other two sides? I have the angle A, but I don't have the other two sides. Remember, I had to have two sides and the included angle. So no, I don't have the side C, so I cannot use my cosine rule. Let's check the sine rule. A over sine A is B over sine B is C over sine C. Yeah? So A, I have A, yeah, so A is what I want to find, and I have this angle here, right? I have B, but I don't have the angle B. I could find the angle B though, yeah. So let's find the angle B, right? Finding the angle B, remember all all triangles is 180 degrees. So 180 minus 93 plus just 180 minus 93 plus 58 gives me 29. So this is 29 degrees. So I find 29 degrees. So I have the side B and I have the angle B. The side A and the angle A. So I could use this. So here A is what I want to find. All over the sine of the angle A, which is sine 93, is equal to B, which is 16, all over the sine of B, which is the sine of 29 degrees. Yeah, and now I can just fling that across. So A is equal to 16 all over the sine of 29, and that is being multiplied by the sine of 93. So A is going to be equal to, let's just work this out, 16 divided by sine of 29 is 33 multiplied by the sine of 93. No, 33. Where's the sine of 93? Sine 93 is 0.998, which is almost 1. So the answer will probably be well close to 33. So right, this multiplied by 33 is 32.95. Scotia, how do you feel?
I'm okay.
You're okay with it? Did you see
Yeah.
how I chose what to use?
Yeah, I chose to do this one too.
So where did you go wrong?
I forgot I could have actually found angle B. I
Oh,
was confused.
you forgot that you could find angle B. Remember, as we move on with trigonometry and geometry and things, it's just like circle theory, where circle theory isn't something separate from geometry. You have to use all of your knowledge from before. Yeah. Same thing with this. You had to use all of your knowledge from before, right? Let me do one last one, and then we'll go. All right. So let's try this one over here. Find the angle C. So you want to find this angle over here. All right. So that's fine, right? So let's see what we have. What do we want to find? We want to find the angle C. So that means that if I use the cosine rule, I'll have to have the cos of C. That means that I'll have to have the side C. Do I have the side C? Yes. Do I have the other two sides? Yes. Right? A. I have the side B. And minus 2AB. So it looked like I could use the cosine rule for this. Alright, good. Alright, so let's just see. C squared is equal to A squared plus B squared minus 2B, not BC, minus 2AB cos of C. And cos of C is what we want to find. Alright? So let's see how this is going to work now. I have C, this is C. This side is the side A. This side is the side B. So I have those two sides. So C squared is 21 squared is equal to the side A, which is 26 squared, plus the side B, which is 16.1 squared, minus 2 into 26 into 16.1 times the cos of C, which is the angle that we want to find. Alright, so 21 squared is 441 and that is equal to 26 squared is 676 plus 16.1 squared is 259.21 minus, I'll just multiply this out, 26 times 16.1 times 2 is 837.2 cos multiplied by the cos of C. So that means that 441 is equal to, let me just add this, 676 plus 259.21 is equal to 935.21 minus 837.2 times the cos of C. Right? So let me flip it around. 935.21 minus 837.2 cos C is equal to 441. I'll take this and fling it across. So I'll be left here with minus 837.2 cos C is equal to 441 minus 935.21. So therefore negative 837.2 cos C is equal to 441 minus that is negative 494.21. So now I take this and fling it across. So I'll just end up with the cos of C is equal to negative 494.21 divided by negative 837.2. Of course, the negatives will cancel, and that is probably where you got the error, right? The error is probably somewhere in terms of the negative, right? So therefore, the cos of C is equal to, let me just read 494.21 divided by 837.2, 0.5903. So therefore C is the cos inverse of 0.5903, which is 53.8 degrees. Scotia, you got anything close to that?
I got that.
Lovely! Yes! How about you, Shizzy?
I did not.
Right, because you made the error. Did you see where you made your error?
Yeah.
Where?
So when I reached down to the part where it was 935.21 minus 837.2, I subtract 837.2 from the 935.
But do you know? Do you understand now why you can't do that?
Not really, to be honest.
All right. Well, let me show you. It's so easy, right? It's so easy. Remember, this cos C, this 837.2 is being multiplied by cos C, and
yes, sir.
And that cos C, that is an unknown, isn't it? Yeah?
Yes.
So what if I had 2 minus 3x? Isn't x an unknown? Yeah? So can I take the 2 and minus the 3 in this situation? Well, that's what you did in this situation. You understand?
Yes.
Yeah, so that 837 is multiplied by the cos C. That 837 belongs to the cos C. You can't touch that. Yeah, that when you, and this is a thing, right? In terms of when we're talking about terms in algebra, and this is kind of beside the point, right? But in algebra we have something called terms. The terms of an equation. For example, a squared is equal to b squared plus c squared minus 2bc cos a. Alright, these are equations. How many terms does this equation have in it? Well, multiplication will actually, because you see 2 being multiplied by b, being multiplied by c, being multiplied by the cos of a, right? Multiplication will stick things together. So that means that this entire thing is one term. Yeah? So once you have things multiplied, that is one term, right? And what you'll find is that addition and subtraction is what will separate the terms in the equation. So I have one term here. Multiplication and division just glue things together, and addition and subtraction just separate things. So I have one term here and one term here. So on this side of the equation I have three different terms. Your terms are usually separated by addition and subtraction, but multiplication and division just glue them together. So that is a real important little thing, right? It's just a little way that you could think about it. If you want another example, we could have 3x squared minus 4x plus 3 is equal to 9, right? We could see here that this is one term, that this being multiplied here, that is one term, and let me just put this divided by 42. We'll put it divided by 42, but guess what? This entire thing is one term by itself. So multiplication and division will join things together, glue them together. Addition and subtraction, they separate them. You all understand this concept? You all get the gist of it? Yeah. So Shazay, you understand what you did wrong there, right? So you're going your trigs lessons here. We did trigonometry 1. Now we're doing trigonometry 2. So trigonometry 2, you will get the document we was just looking at. It's a Google slide, right? And you'll see we didn't do the whole thing, right? We just did the first half of the document. So you have that, all of the things we did in this class, cosine rule, right? And then we had these questions here. 1, 2, 3, 4, 5, 6, 7, 8 questions you are to do for homework. So these 8 questions we will be looking at next class, as well as this worksheet here. This worksheet, let me see, what is this worksheet? Sine and Cosine Rule Introduction. Oh yeah, so this worksheet just has some examples going on here, right? So you could check out examples and notes on the sine and cosine rule, right? And it also have some practice questions coming down to the end, right? So at the end of the day, we are going to try to do some of these questions, these practice questions, and then I have this exercise here. So we're gonna try to do some of these exercises and questions next class, right? We will definitely be correcting these 8 questions next class. We did 2 or 3 of them today, right? So do these 8 questions for homework. Try a couple of the questions from the worksheet, Next class, we will correct these things and we will move on to the rest of trigonometry 2, which is just one rule again. The only rule we had to do again is the sine rule for the area of a triangle. And this is it. The area of a triangle, because you know whenever we're dealing with the area of a triangle, we're always talking about the perpendicular height. But sometimes you don't have the perpendicular height, right? Especially when it's not a right angle triangle, sometimes you just don't have the perpendicular height. So when you don't have the perpendicular height, there is a sine rule for the area of a triangle. And this is it right here. So we are going to be using or looking at that. That is the only formula we have to do next class. This here, right? And then it have a couple of questions on it. And then we have to do this, bearings. Now bearings is a question. All of these questions you see in here are CSEC past paper questions. Bearings is the question that they will test you on sine and cosine rule with, right? When you get a CSEC question on sine and cosine rule, they're not gonna give you this, yeah? They're not going to just give you a triangle and say find that side, you know? No, they are going to give you bearings. So these bearings questions here, we're gonna take a look at bearings next week. So bearings and area of a triangle is what we're gonna look at on Tuesday. Your homework for Tuesday are these 8 questions here. We're gonna see if we could correct them, as well as some of the questions in here if we have time.